Let's begin with a new chapter that is called hydrogen. So you know this one. So hydrogen very well. So this is a simple chapter. So and it's very easy to understand this chapter because you are already familiar with the hydrogen, right? So hydrogen, how do you write this one? That is called capital letter H. That is called hydrogen. So hydrogen is containing the only one proton. So in the nucleus it is present, and this surrounding this nucleus only one electron which is going to be revolving around the nucleus of the hydrogen will be there. So it is going to be combined in the form of like this. That is called element. So hydrogen we are going to this hydrogen molecule we are going to call as element here. Right. So this is an hydrogen where you are going to see the periodic table. That is called the first element in the periodic table that you are going to see in the. So that is called, when you look at the periodic table, the left hand side of the first element is called the hydrogen. So its electron configuration will be 1s1 and its atomic number will be 1. Right. So let's discuss about the resemblance with the alkali metals. So how the resemblance will take place along with the alkali metals. First you should know the alkali metals. Alkali metals, right? So when you look at this group 1 is, when you look at the periodic table, the first group comes, that is called, the order should be like this: the hydrogen, lithium, sodium, potassium, rubidium. So like these elements are going to be placed in the group 1. Why they have placed in the group 1? Because their outermost electron is containing the only one electron. Like this, hydrogen is having the 1s1, lithium is having the 2s1. Like this, sodium is having the 3s1, potassium is having the 4s1, rubidium has the 5s1. So because of this same pattern of this order, last s orbital, the last electron which enters into the s orbital, that they are going to call as the, so one electron will be there. So that's why this comes under the group 1, which is called the alkali metals. So like this, the hydrogen which resembles the alkali metals, and in group 1 all the elements we are going to call as the metals except this hydrogen, because hydrogen is a gas. So let's take here the resemblance with the alkali metals, that is called only one electron in the outermost shell. So like all the elements in the group 1 elements, the hydrogen is also having the only one electron in the outermost shell, and they are acting as a good reducing agents. You know this one, sodium metal, lithium, they are going to be involved in the organic chemistry reactions, right? So at that time they are going to be act as the best reducing agent, and this is similarly hydrogen is going to be act as also best reducing agents. And valency is 1. Obviously its valency is 1. Suppose if the sodium loses one electron, becomes, it is called Na plus, we are going to call it a, right? If the potassium, it loses its almost one electron, 4s1, that is we are going to call as the A plus. Similarly rubidium becomes the Rb plus. So similarly hydrogen also loses one electron, that becomes the H plus. Like this they are going to tell here. And they forms the binary compounds like alkali metals to form the sulfides, oxides and halogens. So because hydrogen is also react with the halogens, that forms the HCl, HBr. Like this also compounds they are going to form. This hydrogen which is going to be react with the halogens compounds, like all the alkali metals, they are going to involve in the bond formation with the halogens, and also oxides, right? The hydrogen is always combines with the oxygen molecules, that becomes the water. That is also we are going to do the rest examples here. So like this also, the like alkali metals, they are going to be formed the sulfides, oxides and halogens. And next one, resemblance with the halogens. So this hydrogen is resembled with the halogens. In what sense, in what manner? Let's study here. The high ionization enthalpy and short of one electron to be to become stable. Suppose if I take fluorine, you know this one, that comes under the halogens. Fluorine, bromine, iodine. So these elements comes under the halogens. So it's contained in the atomic number 9. If I write the electron configuration, 1s2, 2s2, 2p5. 2p5, right? Its nearest noble gas would be neon atom. So right, the neon is the noble gas element. So in order to complete the stable of this fluorine, how many electrons is going to be required here? Because 9 electrons will be there. 2 plus 2 4, 4 plus 5, 9 electrons will be there total. In order to get this stable, so it requires only one electron to attain the noble gas configuration. So that's why it is a requirement of the only one electron will be there. Similarly, hydrogen, its electronic configuration will be 1s1. Its nearest noble gas will be helium. So helium is just opposite to in the form of the periodic table, right? If the hydrogen is comes to the left hand side, the helium comes under the last, that right hand side of the first the element comes under, that is called helium. So helium is unstable because that is also going to be considered as a noble gas. Its electron configuration will be 1s2. So that's why hydrogen is also having the shortage of one electron to become the stable like this. And also ionization enthalpy. So when you look at this one, ionization enthalpy will be very high. Ionization enthalpy or ionization energy both are same. That is called amount of energy is required to remove the one electron from its outermost shell electrons. So it requires, if you remove the one electron from its outermost shell, it requires lot of energy, because if you remove this electron, it becomes neutral, right? No electron will be there. Similarly, in this also case, so this fluorine is in order to take the one electron, right? So that's why it is not going to be lose or easily donate one electron. When you apply the energy, it doesn't give one electron, that becomes 2p4, right? Because it is already nearest to the stable, right? Nearest to the stable. So that's why in order to remove the outermost electron, it requires the high ionization enthalpy. Let's discuss about the occurrence of the hydrogen. So hydrogen is almost, you know this one, so it is going to be in the combined state form, that is called water molecules, carbohydrates. Carbohydrates means glucose, sucrose. So in that one there should be present carbon, hydrogen, oxygen. So in these three format they will be present in the carbohydrates, and also hydrocarbons. Hydrocarbons means hydrogen must be there. So in this way, this combined state with along with carbon, oxygen, they will be going to be formed. That is called occurrence of the hydrogen. And next one, we will discuss about the isotopes of the hydrogen. So before going to study this one, you should know this one, isotopes. When you look at this one, hydrogen, which is going to be in the form of three types of the isotopes. What is the common in that one? That is called atomic number. So this is atomic number 1, atomic number 1, atomic number 1. Only the difference in the mass number 1, 2, 3, right? They must be contained the same atomic number, but difference in the mass number, that we are going to call it as the isotopes. So hydrogen is available in the three isotopes form. So first one we are going to call as the protium. So this name is called protium. This name is called protium because of the number pro means, right? Protium. This is called deuterium. And this is called tritium. This is called tritium. So this among this one, so this is called heavy hydrogen. This should be very heavy. This is heavy hydrogen, and this is the radioactive nature will be there. So radioactive properties of the nature it is going to be having, that is called tritium. So like this, hydrogen is going to be available in the three forms. Let's discuss about the heavy water, that we are going to call as the D2O. So you know this one. So D stands for the deuterium compounds. So this is also a second type of the isotope of the hydrogen. You know this one. Hydrogen is exists in the three forms, right? So protium, deuterium, and tritium. So in that one, second one, that we are going to call as the heavy one because of the formation of this like this. So this is called D2O, stands for the heavy water. So if it is called H2O, if you write the H2O, this is called a normal water. If you write instead of this hydrogen, that is called D, that stands for the heavy water. Therefore, the heavy water is a deuterium oxide. Its name is called deuterium oxide. It is a type of the non-radioactive isotope of the hydrogen that we have studied already. So let's take this about the uses of what is the main uses of this deuterium oxide. So let's take here. It is going to be used as a coolant. Coolant means it is going to make it as a cooling nature because of this heavy nature of this one, heavy nature. So it acts as a coolant, means cooling, and used as the moderator in nuclear reactors. So they are going to be used in the nuclear reactors. And second one, for the preparation of the deuterium and deuterated compounds like, so this is called deuterated ethane. So if I write this compound as like this form, that is called, instead of D I am going to write the hydrogen. So its name is going to be called as the ethane. That is called ethane. So just hydrogen, it resembles like the hydrogen from the deuterium is, it comes from the hydrogen, right? So but the hydrogen is not come from this one, but this is comes from the hydrogen. So this is called an alkyne. If you write like this, CH triple bond CH, this is called alkyne compound. instead of this H, I am going to place the heavy atom like D, that is called deuterium oxide. So D stands for this one, that is called deuterated ethyl compound. And also we should write the CD4. CD4 means deuterated methane. You know the methane. Methane is CH4. So in the place of hydrogen, if you place the D, that is heavy element, so that is also isotope of the hydrogen, that we are going to call as the deuterated methane compound. And also third one, so it is going to be used in the preparation of the other deuterium compounds like, so if you take the CaC2 plus this heavy water D2O, that is going to be formed as the C2D2 plus CaOD2. So once again, so in the place of D, I am going to write the hydrogen here. What happens? That becomes calcium hydroxide. That becomes calcium hydroxide. Next one, sulfur dioxide plus heavy water, that is a D2O. It is going to be formed as a like this. So that is called deuterated hydrogen. That is called sulfuric acid. Deuterated sulfuric acid. In the place of D, you should place hydrogen. That becomes the sulfuric acid. So that's why this compound resembles the hydrogen. So this is also the name is called heavy water. Deuterium is which comes from the isotope of the hydrogen. So this is about the deuterium oxide or D2O.